This is a tutorial on programming starting with pointers, which seems kind of weird if you've had any experience, but I believe this actually makes things simpler in the future. So first I have CodeBlocks open. It's a free IDE you can search for on the internet. Creating a new project. In CodeBlocks you can't see it, but off to the left there's a folder called sources. You open it up and then you have main.cpp, which is main.c++. Basically, this file is where the program starts, the main function. Everything you want to run is in between these two brackets, and then it ends. You don't have to worry about this stuff right now. So in a program, all you're going to do is manipulate bits, and bits are binary numbers like this, and that would be the number 1, 2, 5. So this is the number 5 in binary. If you don't know how to read binary, I suggest finding a tutorial on binary, but don't worry about it right now. Then another bit, which might be the same thing, might not. Let's pretend that's 21. Alright, so that's probably actually 32 or 16. What's 4 bits? 2 to the 4th power. That's 16. Okay, so that probably can't be 21. But if it was, it would be the print statement, so it would print 5. So one of these is an instruction and the other is memory, and all it depends on is where it is in the program. We don't have to worry too much about that. All I want you to know is you are usually manipulating nothing more than ones and zeros, usually in strings of 8 characters. You don't have to think about this too much when programming, but this is what's going on under the hood, and it's the most complex things we'll actually get. So with that out of the way, I'm going to start with a pointer. Now, pointers are things that point to stuff, essentially. So in a computer you have a bunch of memory at the top. Let's just call that the heap, and a bunch of memory at the bottom. And that's called the stack. The stack is what your program runs inside, and it, like a stack, as your program gets bigger it goes up, and then your program gets smaller by finishing a few things, and it goes down, and then it goes back up again, then it goes down and back up. And this is essentially a fast memory. Whenever you create something to use in your program, it goes on the stack. If you want to use a bunch of memory for something that you didn't know how big it was to begin with, then you'd use the heap. And the heap is memory basically on the other side, so on the top here. So let's make the bottom there. And on the top you'd say, oh, somebody wants to enter in a record. They want to enter in someone's name and number. So you'd say make space for a name and a number, but you'd do this in code, of course. And then it would go on the heap. Your program runs on the stack but also uses the heap. Since this is the bottom and this is the top, your limit is the total amount of memory that you can use on either one before they actually collide with each other. And a very good explanation of this is in CS51's lectures. It is freely available on YouTube. I'm giving a short, simple explanation. This will once again make a bit more sense when I put things together. So what main does, as I said before, runs straight through from this bracket to this bracket, and it does what you tell it to do in the order you tell it to do it. So cout is console output, which means print to the little text screen. Hello world is what we're going to print, and this says go to a new line. It's just a shortcut for end line. The return 0 means end the program. Everything went okay. So in the context of what I just said, on the stack it makes room for whatever's inside of main. Then this cout thing is a little object. Basically it's a thing that gets put on the stack as well. So here's, if this was main, this would be cout. It runs with this, which is what you shove into it, and it's data. It translates to zeros and ones. So that gets shoved on the stack as well. And then this just adds another thing to the stack that tells it to go to another line. So we'll call this and this the same thing because it's just one piece of data. Well, it's two pieces of data, but it gets put on the same thing. So let's pretend we're running the program. Let's start at main. So start at main. Let's call it 0. See how it runs, but it's not finished running. So once I get to here, that's running, and then I get to here and it's done. So that stack actually goes away. Then I have to do this return thing, which actually exits the program. Once it's popped completely off the stack, program is gone. Now we'll get to why I am saying this about pointers first rather than variables. Let's say I wanted space to hold an integer. And an integer in a computer is just 4 of these things. So strings of 8 bits give you 4 bytes. This gives you a total of over 65,000 possible combinations of numbers. So that's actually the upper limit to how big of a number you can store inside of an int. So I want to tell the computer that I need to reserve space on either the stack or the heap, and then I want it to store the integer. So I say int for integer. I put a little asterisk saying it's a pointer, which means it's going to point to some memory. You can give it any name you want, so I'll just say pointer equals. And then to create new memory, which gets put on the heap, I say new int. And I can give it a value, so I'd say value of pointer. That's what this thing does right now. You could just call it value of for English sense. It has a real name, we'll deal with that in a little bit. Equals 10. Value of pointer is. We're going to print it. So it's on the heap. Since it's on the heap, we have to get rid of it. It's basically the upper level of memory. So we just say delete pointer, that frees the memory, program ends. Let us run this. You can see that it says value of pointer is 10. In code blocks you press a key to exit. So this is kind of like the same thing with allocation, but instead of a stack going up, it goes on the heap, which is essentially a random spot in upper level memory. So it just creates that, and then the stack's doing its thing, going up, and then the heap disappears. The stack goes away. So you're dealing with memory no matter what. Now let's get into why all this complex stuff is important to understand, why I'm starting a tutorial with probably the most confusing thing that you'd think, but in reality it's going to save you a lot of understanding later. My antivirus program did not like that program. Okay. So, if I don't want a pointer, but I just want a value to go on the stack, it's a lot easier. Int integer equals 10. I don't need all these extra asterisks to be anywhere. Now what this does is it creates a variable, which is just something that stores a value in memory. And it puts it on the stack. And you'll notice that I don't have to, oops, I called it something else. Okay, I don't have to deallocate it afterwards. And it works exactly the same. So this is simpler. Why did I do it after doing the harder thing? Well, let's do this stack analogy. Main starts, call it 0 again. It creates int integer. Okay, it's almost ambiguous name. So usually you'd use more descriptive names that don't match keywords inside the language. But anyway, integers called, cout is called, so here's another one. Notice the stack is 3 high instead of 2 like it was earlier. Okay, so cout finishes. When cout finishes, it's gone, but integer's still on the stack. As soon as the function ends, all of the things that were created inside of the function also get popped. That's the important part. And then the function goes away. So you can think of this as pushing. So int push cout push. Cout goes away, pop. Int goes away, pop. Just like a stack of paper. Last one in, first one out. Make more sense. Last one in was that last one, and it's also the first one gone. It's automatically managed memory, but it's still memory. So it's important to understand the difference between the heap and the stack, because when the heap is running around, so you have another function, which is just another set of brackets with a name to it. And I did something over here. Something. Don't worry about how it's called or any of that right now. So just some English grammar. The code doesn't really look like that, so don't worry. Alright, so if I created something with a heap, if I said point to something and give me space to have an integer and then make its value 10, it would still exist when the function ended, which is really important when you're like making games and you want artificial intelligence to work, because you don't want your AI to just go away as soon as one of your pieces ends. So over here I'd somehow grab it, get integer, and then when I'm done I could say delete integer. It basically exists even though the function above ended, because it was created on the heap. So you can think of the heap as an umbrella, and everything that you create is on top. Everything else is a stack. It gets pushed on and then goes away afterwards. The only limitation with a stack is you have to know how big it should be before you run your program. So you can't just say create 10 records. You have to use the heap for that, and it's a little slower. So that is why the difference is somewhat important. Alright, that ends that.